Hello everyone, Ape is back with a new series, Machine Learning in Python for Dummies. Two items on the agenda for our first lesson. A very quick overview of machine learning, followed by how we can implement machine learning models in Python using an awesome library called Sklearn. We are not going to go into too many details today. My main goal for this first video is to go over a few examples to show you how great Sklearn is. Oh, and I suggest you watch until the end as there might be a surprise for you. Just saying. Let's go! So, forgetting about Python for a minute, what do we mean by machine learning? Sure, there's lots of maths and computer stuff behind machine learning. But the idea of machine learning is actually pretty simple. Instead of providing instructions to your computer, you give it examples. And the machine will learn from these examples. There are two main types of machine learning. The first one is called supervised machine learning. The use case for supervised machine learning is when you have labeled data. For instance, you have pictures of animals and you know which ones are cats and which ones are dogs. Once trained, your model will be able to find out which animal is a cat and which animal is a dog on its own. The other category is called, guess what, unsupervised machine learning. You use it when you don't have labels, and when you want your machine to find patterns in the data. For instance, detect anomalies, without you needing to define for the machine what an anomaly is. There are two subtypes of supervised machine learning. One, regression, when your target variable is a numerical value. For instance, what is the relationship between GDP per capita and happiness? Two, classification, when your target variable is categorical, such as cat or dog. Linear regressions are an example of regression. Random forests can be used for classification, and k-means is a popular clustering algorithm. You'll find links in the video description about how these models work in the background. Before we take a look at how we can implement them in Python, let's see what are the different steps in a typical machine learning project. You usually start with a question. What influences purchases on my e-commerce website, for instance? Then you collect data that's relevant to that question. Where are the visitors coming from? What device are they using? How do my prices compare to the competition? Once you have that, you can think about the model you want to use. Logistic regression, k-nearest neighbors, decision tree. Then comes a step that takes a surprising amount of time, data preparation. Depending on your question and your model, you might want to remove correlated variables, transform your data, deal with missing values, define and remove outliers, or even do a PCA to reduce dimensionality, which you can do in Sklearn, by the way. Then, if you're doing supervised machine learning, you will isolate a portion of your data to train your model on. And once trained, you will fit your model to the remaining portion of the data, called the testing set. Because the model has not seen that data during the training phase, you can evaluate how well it performs. And in real life, you usually iterate several times through this training testing sequence as you make changes to your data or tune your model. If you are doing unsupervised machine learning, then you won't have a ground truth to check your model, so you will directly run it. And another classic scenario is to go back to the model selection stage to try out another one, both for supervised and unsupervised machine learning. Okay, enough with the abstract concepts, let's go back to our beloved Jupyter notebook. And not very original, we're gonna start off by importing the usual suspects, NumPy, Pandas, Pyplot, and Seaborn. And as promised, let's try out the k-means algorithm. I recommend you check out the Sklearn website, it's really well made. Link in the video description. A cool secondary feature of Sklearn is that you can import some standard datasets from it, such as the iris dataset, which we're gonna use for our k-means. If you don't know or don't remember what the data looks like, each row is a flower and we have about them 4 numerical variables plus 1 species column. We can now import the k-means model from Sklearn. And this is when the magic happens. 3 steps you need to follow that are always going to be the same no matter the model that you use in Sklearn. Which is fantastic, because say once you've done a linear regression, then you know how to implement a random forest regression or a logistic regression. All the models available at your fingertips. So, step 1, instantiate. You create an instance of the class k-means. I'm storing it here in a variable called km. I'm specifying 3 clusters because I want to group my flowers in 3 categories to mirror the 3 species available in the iris dataset. Step 2. Fit. This is when I fit the model to my data. Step 3. Predict. In the case of our k-means, this outputs the different labels for each of our 3 clusters. Sklearn, not being super creative, just labels them 0, 1, 2. Quick aside, if I call the function type on our km variable, I can see that we're dealing with a k-means object. Similarly, if I use the dir function, I can see that there are many properties and methods that I can use on my k-means object. Okay, back to the main storyline. Let's print a scatter plot of the original iris dataset with the species labels. Simply looking at 2 variables, we can see on the scatter plot 3 groups of flowers, each corresponding to 1 species. Let's compare that to the labels that we've created with our k-means. Just need to switch the colors here to have a simpler comparison. There we go. Doesn't look too bad, right? Aside from a few points like this one, we've managed to recreate the species with our k-means. Cool, we can now move on to supervised machine learning. Let's try a linear regression first. Here I am generating some dummy data about temperature and ice cream sales. Let's import a bunch of things from Sklearn. First, the linear regression model. Second, the train test split function, another cool feature of Sklearn. And finally, a few metrics to evaluate the performance of our model. The R-square, the mean absolute error, and the mean squared error. I'm storing my features in a variable called x, I only have one here, that's temperature, and my target, ice cream sales, in a variable called y. Then I'm using the useful train test split function. I'm specifying a test size of 25%. That means putting 25% of the rows in the testing set, and the remaining 75% in the training set. By the way, Sklearn offers more sophisticated options to go about this split between train and test, but let's keep things simple for now. Here is what the split looks like graphically. And now is the time to apply our 3 steps: instantiate, fit, predict. We are fitting the model on the training set and predicting on the testing set. And we're done. You've guessed it, we are trying to predict ice cream sales based on outside temperature. The key output is the coefficient on temperature, around 3. And here are the results in the form of an equation. Here is the coefficient on temperature, and here is the intercept. The value of 3 on the coefficient for x can be interpreted as an increase in outside temperature by 1 degree Celsius translates into 3 additional ice cream cones sold. And here are the error metrics that Sklearn has calculated for us. You can see that we get a decent R-square. Here is a graphical representation of our linear regression. The line here is our model, defined by the slope on x and the intercept. Pretty cool, huh? Let's take this to the next level. Random forest, super trendy in the data science community. Again, check out the links in the video description to find out more about random forest. But basically, a random forest is a collection of decision trees. You know, trees, forests, get it? So, technical part, importing stuff from Sklearn. Data-wise, we're using the super famous Titanic dataset from Kaggle. Here is what the data looks like. Each row is a passenger. And what we're going to be predicting is whether they survived or not. And there are different variables that we can use to do that. The passenger class, their gender, their age, whether they have siblings or not on board, things like that. Pre-processing time. I'm creating a feature here, female flag. And here I'm dealing with the nulls. When I say dealing in that case, I just mean deleting them, which may not be the smartest thing to do. But then again, I'm not very smart. See, I've dropped 20% of my data. That's a lot. Here I'm isolating 5 variables as my features, and the survived flag as my target variable. The rest of the code in that cell is just to visualize the linear correlation between the features. It's a step that I like to take. What this red square means here is that there's some sort of positive correlation between the number of parents and children and the number of siblings and spouses on board, which kind of makes sense. Now, train, test, split, followed by our 3 favorite steps: instantiate, fit, predict. With this parameter here, I'm increasing the default number of 10 trees to 100 trees. And that's it. Here is how our model performed. These are the 2 possible values of our target variable. And these are 3 key classification performance metrics. More info in the video description. And what this bar chart tells us is the importance of each feature in our classification. So you can see that fair has the most impact in our model on whether a passenger survived or perished. And finally, as promised, a little surprise. We're going to be playing with Prophet, a forecasting procedure developed by Facebook. Why? 3 reasons. 1, it kind of works like Sklearn. 2, it's super easy to get a decent forecast with it. And 3, it's fun. So let's get cracking. We import Prophet and ignore the warning message. Let's forecast daily public bicycle hires in London. Let's imagine I want to forecast 2019 hires. That's convenient because we know the actuals for 2019 and therefore we can compare them against our forecast and find out whether it's any good. So I'm simply going to split train from test based on date, the 1st of January 2019. And so this is what the split looks like on a time series. And you know what we're going to do now. Instantiate, fit, predict. And we're done. That was easy, right? Let's visually compare our forecast to the actuals on our testing set. Considering that we haven't done any tuning whatsoever, I'd say it looks pretty good. And just like Sklearn, Prophet comes with a lot of cool features, such as a breakdown of the different components of the forecast. Looking at the weekly component, for instance, I can see that bicycle hires are more popular on weekdays than on weekends. Pretty cool, I think. This is probably enough for today. Hopefully, you now have a rough idea of what machine learning is and how accessible it can be with open source tools like Sklearn. As always, thanks for watching. Like, share, subscribe, hit the notification bell, comment to let me know what you think and would like to see next, and remember, practice makes perfect.